This video is hopefully going to show you some different ways of finding the distance between 2 points using Pythagoras. This is a good little lead into higher work as well. So our learning intention is to be able to find the distance between 2 coordinates using Pythagoras. Now there are 3 different methods I'm going to show you here, ranging from simple to more complicated, like you'd be expected to do it higher. So prior knowledge, you should be familiar with the basic Pythagoras and how to plot coordinates by now. So example 1, here we are. We want to find the distance between the points given, A and B. So the first way to find the distance between these 2 points is to do it graphically and plot your points. So -2, 4 would be here. And 3, -2 would be along here. What we then require you to do from there is to turn this into a right angle triangle. Now you can either go down the way or you can go across the way. I'm going to do this and I'm going to make it a right angle triangle going this way. Okay, excuse my lack of straight lines. And then what we're actually after is after the distance between these 2 points. Now there is no way to measure this. We don't have a ruler. We can't do it by counting boxes because the line is diagonal. What we have done though is we've created a right angle triangle, and that should remind us that we can do Pythagoras. Now what we're going to do is we're counting the boxes on the side. So vertically this is a drop of 6 boxes, and horizontally that is 5 boxes. Now be careful, sometimes I have people counting the lines instead of the boxes. Remember, we're counting the gaps. So distance between these 2 points would be using Pythagoras now. So I'm going to call it x because I like x. So x squared would be, it is always alongside if you're finding it using coordinates. So that gives us 6 squared plus 5 squared is 61. Square root of 61 for your last step. And that gives us 7.81. Now I've not mentioned rounding, so I'm going to just say that that's just to 2 decimal places. Okay, obviously it's a longer number than that comes out in a calculator. So method 1 is plot your coordinates, count the boxes, and that is a perfectly valid method of doing it. What we're going to do is I'm going to show you how to do it in a similar way, but we don't have the squared paper anymore. So example, we want the distance between the points 5, -8 and D -2 to 1. So what I'm going to do is I'm just going to draw a wee line and call this C and this D. I'm going to make this into a right angle triangle. And C is at 5, -8. D is at -2 and 1. And I see a lot of people at higher doing it this way when they forget the next way I'm going to show you. And they do it by what's called stepping out. Now, we need numbers along this triangle. So how far is it from 5 to -2? So how far is it from there to there? 5 to -2 is a gap of 7. How far is it up and down the way? So from 1 down to 8, 1 down to -8 is a gap of 9. Don't worry about negatives or anything. So my triangle, without actually having the squared paper, would be 7 by 9. Now just to repeat what I did there, is I thought, right, how far is it from 5 to -2? That got me the 7 along the bottom. And up and down the way I said, how far is it from 1 down to -8? And that got me the 9. Now I can go do Pythagoras to work out the hypotenuse. So x squared equals 7 squared plus 9 squared, which gives us 130. And when we square root 130, we will get 11.40. Again, I'm doing it to 2 decimal places because I haven't asked you whether I wanted it to 1 or 2. Okay, so I call that method the stepping it out method. And a lot of the times, yeah, if you forget the next bit I'm going to show you, this for me is the way I like doing it. Look at the difference between the x's, the difference between the y's. Final method. We want the distance between these 2 points here. And I've told you this as a lead into higher. At higher, you get taught a thing called the distance formula. So here is your distance formula. Now that looks really, really complicated. You're like, whoa. But it does look a bit like Pythagoras. Look, there's a square root. There's some x's squared and some y's squared. So technically it is just Pythagoras at the end of the day. And this bit here where it tells you x2 minus x1, that's working out how far it is between the -5 and the 2. And the y2 minus y1 is working out how far it is between the 3 and the 6. Okay, which I did in that previous example. But we're going to do it using the formula. So let's go with this being our first coordinate and the other one being our second coordinate. So I'm going to call this x1, y1, same as we would have done if we're doing gradient, if you've seen that already. So our distance formula would be 2 minus 5 all squared plus 6 minus 3 all squared, and then a big square root all over that. So 2 minus 5 is 2 plus 5, so that would give us the square root of 7 squared plus 3 squared, which would give us the square root of 58, which is 7.62, again to 2 decimal places. Okay, now that's the distance formula. Personally, I prefer example 2 method, where I just look at the coordinates and say, okay, from -5 to 2 is a gap of 7, and from 3 to 6 is a gap of 3. And that's where the 7 and the 3 came from in my formula. Look at that. Okay. So what I've got now is so there are some here graphically. So the first 3 are doing it by making the right angle triangles. And then the next lot, I haven't mentioned what to do there, but go with 2 decimal places again. And the next lot are by using the coordinates. So you choose whether you want to use method 2 or method 3 there for those ones. All right, and then pause while you try them, and your answers are on the next slide. So what have we learned? Hopefully you've learned how to find the distance between 2 coordinates. There are obviously a choice of methods, and which one I teach depends on what class I've got in front of me at the time. But I've shown you the 3. See which one you prefer. I definitely like number 2, but number 1 is the foolproof way of doing it. Okay, best of luck.